So next one is your unit 4, material characterization testing. So the material characterization testing involves the various characteristics can be studied with the help of microscopes. That is material characterization testing. In second unit and third unit, we have seen about destructive and non-destructive testing. This is the overview of the unit which is describes how the material can be prepared and studied with the internal molecular arrangement that can be studied with the help of the microscopes. So what are the parameters that can be studied by using some microscopes or some magnetic techniques or spectroscopic techniques is the contaminants, purities, active ingredients, polymers, fillers, solvents, failure analysis, material comparisons. These are the parameters you are going to read with the help of this material characterization testing. So these are the methods involved. First one is your chemical characterization. Second one is your toxicological characterization. Third one is your physical characterization. Fourth is your electrical characterization. Fifth, morphological. Sixth, mechanical characterization. So main objective of this characterization testing is you are going to study both the physical and chemical properties of a materials subject to any shape or size with the help of some external equipment such as microscopes. These are the applications behind this testing methodologies. You are going to analyze your surface, defect analysis, analytical imaging, near surface and subsurface chemical analysis, etc. So classification of material characterization is broadly it is classified into three categories. One is based on the composition and structure. Second one is based on performance. Third one is based on the properties. So first the composition and structure. This deals with the bonding and microstructure and surface topography analysis. Next, the performance. The name itself indicates the performance of the material can be identified. As it says, the performance in the sense, the corrosion, friction and wear. These are the factors which are going to affect the working of a particular specimen or anything. So that is the performance category. Next one is your properties. So mechanical, thermal, electrical, magnetic and optical properties can be tested with the help of some macroscopic equipments. And the composition and structure can be studied with the help of microscopy and spectroscopic testing. So directly we'll go to some microscopes. So the microscopy technique is mainly used to deduct the composition and structure of material. As I said previously, the composition and structure of a particular material can be studied with the help of microscope as it is not visible with a human naked eye. So these are the properties. These are the instruments. So previously they have used some optical microscopes which works based on the principle of light. So without light, this microscope will not work and the image cannot be obtained clearly and it cannot be magnified in a zoom view. Next, later they have developed a SEM and TEM. So that is a scanning electron microscope and a transmission electron microscope. These are used as an advanced technique. So macroscopy in the sense, so next one is your optical microscope. This macroscopic view in the sense without the aid of any external devices, we can identify the cracks or defects in the specimen. So that is a macroscopic view. Microscopic view is it cannot be viewed with the help of the human eye since the particle size is very minute. So with the aid of some external devices such as microscope, we can magnify the particle size and we can identify the molecular arrangement, structure, and composition of various elements present in particular specimen that can be identified with the help of microscope. So as I said earlier, the name itself indicates optical. Optical is based on the light. Without light, these microscopes cannot use to find the defects or composition or structure of a particular material. It is a basic principle. It is based on its ability to focus a beam of light through the specimen, which is very small and transparent, to produce an image. That image is a minute particle. So the beam of light will be passed on this image specimen. That image of light specimen will be displayed here. So once with the aid of light only, that image can be obtained. Without the light or during the night time, with the absence of any external artificial light and sunlight, this process will not be done under darkness. So various types of microscope: bright field, dark field, polarized light. These different types of microscopes are used for different applications. For example, if polarized microscope is used to determine the crystal orientation. So as you already aware of, crystal orientation is a lattice structure, that 14 shapes, no? So we already aware in physics, that is used to determine the structure of particular objects. So that is lattice structure. The 14 shapes, no, 14 types of crystal lattice structure that can be viewed with the help of this polarized light microscope. So this is a cross-section view of optical microscope. So this optical microscope will has a tendency of light will be focused on the specimen. So the specimen is placed here. In this place, the entire these lenses are used to focus your beam of light. The beam of light will be focused on the specimen, and this, with the aid of this light rays, the specimen will reproduce an image at the end. So that image can be viewed with the help of this microscope. So once this is affixed with the digital camera system, which is used to transmit the light in a biological microscopes. So the digital camera will be used to focus the light. The transmitted light will be focused on the specimen place. The specimen is placed here. That specimen will reproduce an image that can be viewed with the help of some external lenses. This is a cross-sectional view. So the major advantages of this optical microscope is it is easy to use. There is no any skilled labbers or any training is required to enlarge the image, and it is a small and lightweight device. It offers high level of observation quality. The quality of image obtained with the help of this optical microscope is very high, and it is not affected with any electromagnetic waves. It doesn't require any radiation to operate, since operation is based on the light waves. Requires very little training. There is no much training, difficult training is required to view the object or deduct the object molecular structures and all. The major disadvantages is light. As I said earlier, with the help of light only it can operate. So it cannot operate on darkness. That is a major drawback of this optical microscope. It cannot provide the three-dimensional image, since it is since a scanning electron microscope and transmission electron microscope can be able to produce a three-dimensional image, but it fails in this case. The poor surface view and separate sample preparation is required in order to place that sample in a anvil, similar to that of previous. The anvil is nothing but a stage. Application. So it is widely used in nanophysics, biotechnology, pharmaceutical research, medical diagnosis, and microelectronics. These are the various applications of light microscopes, optical microscopes. So the electron microscope is broadly classified into SEM and TEM. TEM is nothing but transmission electron microscope. SEM is nothing but scanning electron microscope. So it is used to a beam of instead of light, the electron beam is passed. That electron beam is passed at the specimen. So once the electron beam is passed, the specimen will start to observe some of the electrons and reflect the remaining electrons at various directions. Depends upon these emitted directions wavelength, that composition, structure, and topographic, geometrical information, everything can be obtained with the help of this wavelength of emitted or scattered electrons from the surface. That is in terms, they are called as primary, secondary, and tertiary electrons.